which is square root only, or we have radicals in the numerator but we don't have the denominator. Now we're taking only the square root. We can have also the 4th root, 6th root, 8th root, 10th root. But this one is not applicable for cube root, 5th root, 7th root, or this one is not applicable if the index of the root is an odd number. This is only applicable if the index of the root is an even number, 2 square root, 4 fourth root, and so on and so forth. Now, if we have this function y equals square root of x plus 5, this part here inside the radical sign is called radicand. So we are just going to get the radicand and set it to greater than or equal to 0. Because we can have a 0 here, we can have an answer of 0. It is not in the denominator, so we can have 0 here. But square root of a negative number is not, it is imaginary number. So the value here of our number must not be negative and it must be greater than 0. Because when I say greater than 0, it means we have a positive number. But it could be also equal to 0. So don't forget this one. If you have only radicals in the numerator, equate the radicand to greater than or equal to 0. So we have two examples here. One is here, the other one is there. So let's take the radicand here. X plus 5, and then must be greater than or equal to 0. Then we solve. We transpose this one there. So if x is greater than or equal to negative 5, then we will make in number line. It's better to always make in number line so we can see it clearly. So here we have this one. This one is the negative infinity. This one is the positive infinity. And then we place the negative 5 here. This one's negative 6 going down. The value is decreasing. And we have negative 4 here. Now, let us check if negative 5 is included or not. So here we can see that our negative 5 is included because of the equals here. X is equal to negative 5. So we are going to say this one like this. Okay, it's included negative 5. Let us check the number on the left. Check this one. Negative 6. So we have here negative 6 is greater than or equal to negative 5. Is it negative 6? Is it greater than negative 5? No, because it's on the left of negative 5. Is negative 6 equal to negative 5? Of course no. Therefore, all the values to the left of the negative 5 is not included. So erase here. What about the negative 4? So here we check. Negative 4 greater than here to negative 5. Is negative 4 greater than negative 5? Yes, because negative 4 is on the right of negative 5. So this one is included. So what is the domain here? So the domain here is we start from here. We will not include the negative infinity anymore because from the left of negative 5 it is not included in the domain. So start from -5 and -5 is included. Therefore, is that one? Symbol of inclusion. And then we write -5 all the way to positive infinity here. Not this one, that one. Always for infinity. So that is our domain for this example here. The second example here. We take the x squared minus 4, x squared minus 4, and set that one to greater than or equal to 0. After that one, we'll find the values of x. You can transpose this one on the other side, or we factor. Which do you want? Okay, let's factor. Listen, what this one is difference of perfect squares. So x plus 2, x minus 2 is greater than or equal to 0. Then we equate this one here. X plus 2 is greater than or equal to 0. And then we transpose x here is greater than or equal to -2. And on the other side here, x minus 2 greater than or equal to 0. Transpose x is greater than positive 2. Then we form or we draw our number line. So I'm going to draw here our number line. This one is negative infinity. This one is positive infinity. I'm going to put the 0 here. Okay. And I'm going to put -2 on the left here. And then we have the positive 2 on the right. Okay. Now, is -2 and positive 2 included in the domain? That is the first test. So here, you have the -2 here. If you place a -2 on the x here, so we have -2. And then we have that one to -2. Is -2 greater than -2? No. But is -2 equal to -2? Yes. So this one is yes. Therefore, the -2 is included. So I'm going to put a shaded circle there. It means included. What about this one? Let's check the 2. 2 is greater than or equal to 2 here. Is 2 greater than 2? No, but 2 is equal to 2 here. Yes, here. So the 2 is also included. Okay, now we have 3 areas or 3 regions to check or to test. The first region is from -2 to negative infinity. Here, first one. The second is this region or area here between -2 and positive 2 here. Second. And the third one is from positive 2 to infinity, positive infinity. So we are going to check these 3 areas. Now, we select a number to the left of -2. You can have -3, -4, -5, but just select a number which is nearer to -2, and that one is, let us have the -3. For this one, you just choose the 0. If you want, you can choose the -1 here, or the +1, but it's better to use the 0. And here, we'll use the 3 to the right of 2. Okay, let us check now this one, -3. So we have here, negative 3 squared minus 4 is equal to 0. So negative 3 times negative 3 is positive 9 minus 4, 0. 9 minus 4 is 5, which is greater than 0. So this one is okay. So this one is okay. So the area from negative 2 to negative infinity is okay. Now let us check the 0. So for 0, we have 0 squared minus 4 is greater than or equal to 0. So here it's 0. Negative 4 greater than or equal to 0. Is negative 4 greater than 0? No, because it's on the left. Is negative 4 equal to 0? No. So this one is not. So this portion here, this area or region here is not included. So this one is not. We have an okay there. This region is not. Then we check the region from 2 to positive infinity. So here again, we check the 3, not the 2. So you have 3 squared minus 4 should be equal or greater than 0. 3 times 3 is 9 minus 4, 0. 9 minus 4 is 5 greater than 0. Is 5 greater than 0? Yes. So this one is a yes. Then this one is okay also. Now, what is the domain of that one? So we write the domain. The domain is, can I take this one first? Write the domain here. The interval notation for the domain of that one is this one. We start from the negative infinity to negative 2, and negative 2 is included, right? Here is the negative infinity. Then we have the negative 2, and the negative 2 is included. From negative 2 to positive 2 is not included. Then we start from 2, union with, and the 2 is included. That's why it's a bracket. So we have 2 here, going to the rightmost, which is this one. This one is like this. And that's the solution for this function.